Hello guys, and welcome back to another episode of chemistry. All right, and in this episode I'm going to be looking at the uses of radioisotopes. Okay, I'm going to be looking at the uses of what? Of radioisotopes. Okay, so I'll be talking about radioactivity. I want to see what the use is. Okay, that will draw all right from what? From radioactivity. Okay, and do not forget that this tutorial is brought to you by the O3 School JAMB app. So do not forget to like this video. Don't forget to subscribe to this channel and do not forget to keep sharing. All right, so let us see a question concerning this. So questions on this come out a lot, so you do not play with this at all. Okay, they say, how does, this is a 2023 question number 8. 2023 question number 8, it says, how does radioactivity contribute to the preservation of food? Okay, how does radioactivity contribute to the preservation of food? A, it helps to cook food at high temperatures for preservation. B, it is used to create artificial preservatives for longer shelf life. C, it helps to sterilize food products to prevent spoilage and contamination. D, it contributes to the development of genetically modified foods. Okay, so now I'm going to come back to this question, all right, and then of course we will would answer this question and many more questions on this application. So do not forget to go to Play Store immediately, download the application and start practicing your way to success. It has all you need to succeed. It has all the past questions, all right. It has question start feature. There's a what? Also a classroom that contains lecture notes structured according to the JAMB syllabus. There's also the UTME mock challenge. Every Saturday you participate with your mates, you win prizes, all right, and then you get used to JAMB past and likely exam questions. You see your score release, your results release every Saturday. It builds your confidence toward the main exam. You know, go come the fear when they say JAMB don't release result waiting no good. You go wrong, go check them. All right, please let me wear my glasses and let me join you in a bit. Okay, so now I'm going to be looking at what are the uses of what? Of radioisotopes. The uses of radioisotopes. Okay, so now radioisotopes found were uses in what? In many what industries. Okay, you find in many what fields. Okay, in medicine, in agriculture, all right, mass spectrometry, dating techniques, tracing techniques, and the like. So I want to begin with the usefulness in what? In medicine. Let's begin with what? With medicine. Okay, so now number 1, cobalt 60 and gamma rays are used to treat cancerous cells. Okay, cobalt 60 and gamma rays are used to destroy cancerous cells. Number 1, cobalt 60 and gamma rays, okay, or gamma radiation are used to destroy cancerous cells. Okay, so please take note of that. Okay, so cobalt 60 and gamma rays or gamma radiations are used to destroy cancerous cells. Okay, also we have iodine, which is used to treat thyroid cancer. Number 2, iodine. Okay, that is radioactive iodine. Radioactive iodine is used to treat thyroid cancer. Okay, they used to treat what? Thyroid cancer. Please take note. Okay, so radioactive iodine is used to treat thyroid cancer. Radioactive iodine is used to treat what? Thyroid cancer. Then also we also have phosphorus 12, which is used to treat leukemia. Phosphorus 12, number 3. Phosphorus 12. This one is used to treat what? Leukemia. Okay, all right. So that is what phosphorus what? 12 used to what? To treat what? Leukemia. All right. So please take note of that. They also have what? Nuclear batteries. Number 4, nuclear batteries. These nuclear batteries, they are used as what? As artificial pacemakers. Okay, they are used as what? Artificial pacemakers. I'm going to explain in a minute. Pacemakers in the heart of patients. In the heart of patients. Okay, these nuclear batteries that what implanted into the heart of patients. Okay, and then it helps what the patient to what or help what diagnosis or help the doctor to what to calculate the what heart rate and what and do some simulation. So it's like wire that is connected to the what to the heart. Okay, so these nuclear batteries find application in what artificial pacemakers. Okay, in the heart of patient to check what their heart rate and simulations. Okay, so these are the applications of what of medicine. There may be more, all right, but these are some of the applications of medicine, of what radioisotopes in medicine. Okay, so please, you are expected to commit them to heart, all right, cobalt 60 and gamma radiations are used to destroy cancerous cells. Iodine, okay, that is radioactive iodine is used to treat what thyroid cancer, while phosphorus 12 is used to treat leukemia, and then of course nuclear batteries that are used as artificial pacemakers in the heart of patients. Okay, now let's just look at another field. Let's look at agriculture. Okay, agriculture. Now radioisotopes are also useful in what? In the agriculture world field. Okay, radioisotopes, all right, they have what? Their radiations. Their radiations are used to induce. Their radiations are used to induce and produce better desired species. Okay, their radiations are used to induce better desired species in agriculture now. In agriculture. Okay, so number one. Okay, we say that their radiations, okay, that's what? Radioisotope, their radiations are used to induce better desired what species of plants. Okay, so that is one use. Okay, their radiations are used to induce mutation and produce better desired species. Okay, so that is what one application of what of radioisotopes in the agricultural field. Okay, the radiations from radioisotopes are what used to induce mutation. Okay, and what to produce what better desired what species. Okay, so please take note of that. Likewise, radiations are used to render male species of insect vectors and pests, okay, sterile, so that their population is reduced. Okay, you know that what hampers what productivity of plants. Okay, how plants produce is what is pests. Okay, and insect vectors. All right, they can destroy plants. Okay, so what to do is that use radiation to render male species. Okay, of those insect vectors and pests, so that to render them sterile, so that their population is reduced, so that they will not be able to reproduce. Okay, because the more they produce, the more the problem. So if we render the male species of sterile, okay, then of course their population will be reduced, because reproduction will be cut short. Okay, so that's another application of radioisotopes in agriculture. Okay, so now let's quickly look at the industry. Okay, the applications of radioisotopes in the industry. All right. Okay, so cobalt 60 is used to trace any faults. It's used to trace any faults in welds, like welding. Okay, in welds. Cobalt 60 is used to trace any faults. Okay, in welds. All right. So let us see in the industry. Okay, number one, they are used. Cobalt 60 is used. Cobalt 60 is used to trace faults in welds and castings. Okay, please, you must take note of that. Cobalt 60 is also very useful to trace faults in welding. Okay, where parts that have been welded together. Okay, it's used to trace faults in welds and in castings. Also, it's also used to check for leakages. Okay, it's also used, number two, it's also used to check to check for what? Leakages. All right, it is to check for what? For leakages. It is to check for what? For leakages and thickness. And thickness. Let me add that. And thickness. Okay, it is to check for leakages and thickness. Okay, so please, that is what in the industry. Cobalt-60 is to trace faults in welds and castings, and then they are used to what? To determine and check leakages and thickness. They also used to control the filling of tins and parts. They are used to control the filling of tins and packs. Okay, so these are what where the areas whereby radioisotopes find application in what? In the industry. Cobalt-60 to trace faults. This one is very important. Cobalt-60 to trace faults in what? In welds and what? And castings. To check for leakages and what? And thicknesses. And they are also used to control the filling of tins and packs. Okay, so likewise, we now go to another word field in sterilization. Okay, sterilization. Okay, so another use of radioisotopes is in what? Is in sterilization. Okay, sterilization. Okay, for example, surgical instruments. Okay, surgical instruments that may contain what? Contaminants. Okay, so we can use what? Use radioisotopes to make what? To sterilize what? Those what? Equipment. Okay, so that what? Contaminants will be removed from them. Okay, so in sterilization, surgical instruments can be made sterile. So surgical instruments can be made sterile and free from contaminants by passing gamma radiations through them. Okay, so this one is also what? In medicine. Okay, in the field of medicine. So surgical instrument can be made sterile. Okay, can make clean. All right, and free from contaminants by passing gamma radiation through them. Okay, so the radioisotopes also find what? Application in what? In sterilization of what? Of surgical instruments. Then of course we now have tracing techniques. All right, all right, and of course in medicine, tracing helps to what? To identify faults and abnormalities in organs. Okay, to identify faults and abnormalities in organs. Okay, so let us see tracing techniques. In medicine, tracing helps to see any faults and abnormalities in organs Okay, so in medicine, tracing helps to see any faults and abnormalities in organ. Okay, so instead of maybe a particular organ, okay, that is what malfunctioning. All right, so instead of you to tear the person open and then be looking for where the problem is coming from, you can just simply use tracing techniques. Okay, and then it will identify the particular organ that has the fault. Okay, and then you can easily operate on it. Okay, so it's as simple as ABC. So in medicine, tracing helps to see any fault and abnormalities in organs and this of course will in the long run help diagnosis. Okay, so you can say that and this helps diagnosis. Okay, and this helps diagnosis. Okay, so it helps the doctor to easily identify the faulty organ and be able to operate on it without wasting too much time. Okay, also the pathway of chemical reactions may be studied using radioisotope. The pathway of chemical reactions can be studied using radioisotopes. Okay, the pathway of chemical reactions. Okay, all right, the reaction pathway. Okay, the reactants to turn to a product. Okay, it can be studied using what isotopes. All right, so that is also another application of radioisotope in tracing. Okay, so that's a tracing technique. Okay, then likewise, we'll now look at dating techniques. Dating techniques. Okay. All right. The ages of specimens, rocks, and even the earth can be estimated, okay, using dating techniques, okay? So what it does now is estimates, okay, and finds which of the specimens that have longer half-lives. Okay, we are going to talk about half-life soon, half-life and decay constant. Okay, so the dating techniques, okay, you can easily make us to know. Like, I can tell you that if you bring a bone now, they can tell you that this bone has lived so and so years. Okay, that is what dating technique does. It makes us to know the age. Okay, how long something has lived. Okay, so it's as simple as ABC. If you see a rock now, they can use dating technique to estimate how long that rock, okay, has been existing, okay, or has been in existence. Okay, so it's as simple as ABC. So dating techniques, okay, the ages of specimens, and say the ages of specimens, rocks, and even the earth can be estimated by determining the amount in these specimens of certain isotopes, okay, that have long half-lives. Okay, please take note of that, long half-lives. All right, so it's as simple as ABC. So the ages of specimens can be determined. Okay, what to do? It can be estimated by determining the amount in the specimens of certain isotopes. There are some isotopes that will know how long they are. Those isotopes will have existed. So if you see those isotopes, okay, in those specimens, we can use to estimate or determine the length of life, or how long that specimens has lived. Okay, so dating techniques is very, very, very useful. And of course, the common radioisotope that is used, for dating is carbon-14. Okay, please take note, carbon-14. This will be an exam question. It's an exam. This is an exam question. Okay, so carbon-14 is used for for dating techniques. Okay, so now let's go to mass spectrometry. Okay, mass spectrometry will enable chemists. Okay, mass spectrometry will enable chemists to measure the mass of various isotopes. Okay, to measure the mass of various isotopes. Mass spectrometry. Okay, this will enable chemists to measure the mass of various isotopes present in a given sample of any compound. This enables chemists, okay, to measure the mass of the various isotopes present in a given sample of elements. Okay, as well as their relative abundances. Okay, so this enables chemists to measure the mass of various isotopes present in a given sample of elements. Okay, so for example, now when we say hydrogen has 3 isotopes, okay, the proton, the deuterium, okay, and the tritium. Okay, so mass spectrometry we enable chemists, okay, to measure the mass of the various isotopes. This one has a mass of 1. Okay, mass number 1 here, mass number 2 here, mass number. How did they determine it? Mass spectrometry that enables chemists to measure this masses, okay, present in a given sample of elements, as well as their relative abundances. Okay, so that is that. But these are the uses of what, of radioisotopes. So what is left now for us to go to the what, to the app and what, answer some questions to cement our understanding. This is a 2005 question number 34. They say 1, treatment of cancer. 2, detection of leakages in water mains. 3, detection of the ages of ancient tools. 4, preparation of what, of drugs. Okay, they say which combination of this of the above refers to the uses of radioisotopes. Okay, which of the following refers to the uses of what, radioisotopes. Okay, as you can see, radioisotopes is what, find application in the treatment of cancer. Okay, all right. Then 2, detection of leakages in what, in water mains. Okay, we talked about what, cobalt 60. Okay, then detection of the ages of ancient tools, talk about what, carbon dating. Okay, then preparation of drugs is very, very useful also in the preparation of what, of some what, radiopharmaceuticals. Okay, in preparation of what, of drugs. So the correct answer there will be option D, 1, 2, 3, and 4. They are all uses of what, of radioisotopes. Now they say number 2022 number 8. 2022 number 8 says, which of the following is not an importance of radioactivity? Is not an importance of radioactivity. A, they say irradiation. Okay. B, they say carbon dating. C, they say smoke detector. D, they say cancer transmission. Cancer transmission cannot be what, a use. It's not an importance of what, of radioactivity. All right. Of course, it's used in what, in irradiation. All right. Then also B, in carbon dating. C, smoke detector. Okay, smoke detectors use the ionization property of what, of radioactivity. Okay, so they are also used, but cancer transmission is not part of them. All right, so these are many more questions on the O3 School JAMB app. So please ensure what, we go to the Play Store immediately, download the app, start activating, and what, start practicing immediately. All right, so I'll see you in the next class. Thank you for watching.